Welcome everybody to another episode of Bitcoin Talks, where we talk about existing and working Bitcoin professionals and developers throughout the industry. And today we have with us Stratospher, who is a super lunar grantee and working on Bitcoin Core on a very important project on P2P network privacy layer, implementing BIP324 and working with the BIP324 team. She has been alumni of Summer of Bitcoin, and since then she has been working and contributing heavily on Bitcoin Core and Bitcoin related other infrastructure project. So welcome Stratos, thanks for joining us.
Hey Raj, excited to be here.
Nice. We are also excited to have the conversation with you. To start with, why the name? What does this name mean, Stratosphere? It's kind of like stratosphere, but it's not. So what's the story behind it?
I wish there was some great story, but actually, no.
Okay,
Uh,
so it's
all
all
usernames,
it's just
yeah, all
it could be a typo at the end, like
no, all usernames are taken. Like current generations are finding it really hard. I wanted Stratosphere, but
right.
then
And
I
now
had to
it's
cut off
taken.
the E.
That's sad. Okay, but it still end up being a cool name, nevertheless, right? I wish I started with a pseudonym, but history is history. Tell me a bit about yourself. Like, how did you got started into Bitcoin, and how did the journey look like?
Yeah, I was in college pursuing my computer science degree, and I heard about Summer of Bitcoin and applied to
Mhm.
it. Uh,
Okay.
in college, like you get to explore anything you want.
Hmm.
So there's always all these trending technology which everyone's learning, like web development, machine learning, and all those.
Right.
So I did a couple of internships in some of those domains, but everything felt very empty. Like I had no clue why I was doing it, and there were too many baseless requirements and expectations. And
Right.
then
And then you found Summer of Bitcoin. And if I remember correctly, that was the first Summer of Bitcoin internship program started. It was the inaugural year, right?
yeah, it was in 2021. I did
Right.
not
So,
expect, yeah, at that point of time, I did not expect to turn out this good for me.
yep, yep. But as it happens when Bitcoin touches, it touches hard, right? And
Yes.
so when you first heard about Summer of Bitcoin, you probably did not had any history of that internship program because it didn't existed before. None of your friends heard about it. So how did you go about choosing like this is seems like an obscure, weird thing that is happening for the first time. Let me do it.
Yeah, like that point of time, I had like almost tried all the domains except blockchain. Blockchain is the
Okay.
trending word in colleges. I had always
Right.
kept away from it because I was very, very skeptical of it.
Mm-hmm.
So it is just total chance. I thought, okay,
Right.
this is something I have no clue about. Let me go learn the
It would be fun
fundamentals.
exploring.
Yeah.
Right. So before Summer of Bitcoin, did you had any other exposure of blockchain or your friends were into blockchain and there are like blockchain events and curriculum that keep happening in colleges. So were you exposed to those?
Like I had friends who worked on blockchain, but I had always kept away from it because I was very, very skeptical of it right from the very
Mhm.
beginning.
Okay, what made you skeptical about it? The
I
claims?
thought it was, yeah, I don't know. I never learned the fundamentals. I always thought it was something like stocks for people to make money.
Right. Uh-huh. It definitely has a vibe like that. So, okay,
Yeah.
fast forward, then Summer of Bitcoin happened, and then you started doing your internship. So, how was the journey look like in Summer of Bitcoin? What kind of studies you were doing, and what you end up working on as an internship project?
Yeah. So we had a lot of technological discussions, like how Bitcoin works from the fundamental level. Uh, we learned grokking Bitcoin and Kalle Rosenbaum. I hope I didn't slay his pronunciation. He did a whole session and explained to us how Bitcoin works. And we also had a lot of study groups where we would come and discuss questions about Bitcoin. And I got that
Right.
technological clarity. And then
Right.
for my project, it was. on Bitcoin Core. So I started by writing some first tests for cryptographic algorithms.
Right. Okay. So you were always interested in the cryptography and the maths and those domain of the Bitcoin protocol layer rather than building wallet or an app or things like that.
Yeah, like I mean, I was very interested in maths. So this was the first time, like before Summer of Bitcoin, I never knew that technology could be built at the protocol level. I mean, I knew it existed, but I had never seen people working at protocol level technology. So I was immediately fascinated and drawn to it. There's all this intricate dance between distributed systems, computing, cryptography, networks, and I really wanted to
Wow.
learn how everything works. But I did not know
So,
cryptography. I learned
right.
it for Summer of Bitcoin.
Right. So how did the study path look like? Like Summer of Bitcoin gives you to certain level, and then after the internship program, you get a slight bit of flavors of the starting of these ideas. But when you start working as a professional dev in the space, you need to cover basics of cryptography, internet protocol, networking systems, and all these things. So how did you cover those basics, or like you already had them from your curriculum in the college?
Yeah, I knew the very basics from college curriculum, but like as I like one skill I picked up doing Bitcoin work is that everything can be learned. So
Right.
it's kind
I
of
think
like
that's
you pick
probably
up
the
this.
most valuable skill to pick up in the Bitcoin world, because eventually it doesn't stop.
Yeah, yeah, and that's the most efficient way to learn too.
Right. So, and after Summer of Bitcoin, you decided to work professionally in this space. And what motivated you to do that? Because like most of the cases, the college grads, the computer science, they went for Google, Apple, Fangs, and the big techs, and going for the high security job, or maybe like try to land on Silicon Valley. What made you stick to Bitcoin?
Firstly, the technological thing, like this was very exciting. It's protocol level technology. That is something which I was very fascinated by and wanted to work on.
Mm-hmm.
And I don't think you'd get that kind of experience if you work in companies like Google, or they'll be building higher up on the stack, though
Right.
there might be
Yeah.
exceptions.
Yeah, and here it's like almost like you get to work directly on the bottom layer of the next generation digital monetary system, and
Yeah.
that's pretty exciting to work on.
And
And
it's all open.
it's
It's
all
all
open, right?
open.
Totally, yeah, and anybody can see it, anybody can change it. At the same time, like it also comes with lot of resources and documentation. But the thing is, like, it's not very well organized, right? So if you want to learn XYZ, there is no one particular spot you can go and learn XYZ. You kind of have to scour up in Google, and they will most probably find multiple different variations depending on what kind of things you are looking for. And but at the higher level of the stacks, if for example, if you are like looking for some specific answer of a deep Bitcoin technical question, other than Bitcoin stack exchange, if nobody answered there, they probably the question answer doesn't exist. So did you find it difficult at your start of the journey to scour up resources, or find out documentation for things you needed to do, or you managed to find it most of the time?
I, I actually like learning by finding resources in multiple places and
And
what.
combining them together to kind of
Yeah,
like
yeah.
get
I
the
really
best.
enjoy that. Yeah.
Right. And that's kind of like the process also, that kind of process also helps into understanding Bitcoin development, right? So and how did you went about going for the grant? Did you apply for it? Did you made a proposal? And how did the process look like?
Yeah. I reached out with all my past contributions to Superloaner, and uh, we did a few calls and
Right.
the grant. Like that's
And
how it
then
went.
you dropped into BIP324, which is kind of like an heavyweight P2P layer protocol engineering challenge, right? And you already had it mind from like the time of application of your grant that that's the kind of project you want to work on, or how did the BIP324 idea came along?
Yeah, like all this cryptography, which I was first testing for during my summer of Bitcoin, it was for BIP324 to use for the encryption in that. So I kind of had it in mind that I wanted to work on BIP324.
Right. And cool. And since then, you have been like heavily contributing into there. And so we'll jump into BIP 324, the details of it. Before that, what would you suggest as a possible path forward for like any other aspirants who might be listening to our call and going for the same kind of questions? Like, what does the path look like for any college students or any software developers looking to get into Bitcoin development? It can be a very elaborate answer, but what does your sense looks like as a suggestion for somebody at the starting level but very much motivated to get into the space?
Do you mean exploring the Bitcoin Core code base? Or,
No, I mean like getting into Bitcoin development as a career.
ah, like whether it is super exciting.
I mean,
I
like,
don't think I,
what would be the process would you suggest to your friend, as like if somebody comes and say like, I like what you're doing, I like the idea, I don't know where to start. What would you suggest to a friend like that?
oh, I would tell them by like to start with exploring Bitcoin Core code base and review PRs, understand what kind of contributions people are making in this space. See if you can make contributions. Learn what's happening at the fundamental level by using debuggers. Uh, Run a node, get your hands dirty, read the log files,
Mm-hmm.
and
Right.
it's a proof of work kind of system. Even like normal companies hire based on your potential. Here they hire based on your past contribution history. So
Right.
if you can build a good enough contribution history, you'll get a grant really easily.
Right.
Hopefully.
Yep.
Yeah.
Yeah. And or you can even like get a job, or you can like and most of the cases like in Bitcoin works, like the reason companies don't go by credentials or like your college degrees or grades is like they don't really measure your capability or willingness to work on Bitcoin. So they majorly both the grant programs and people hiring for different kinds of like Bitcoin startups and Bitcoin projects, they generally go for the proof of work mechanism. That's a good suggestion. Like for proof of work, there is like no real like straightforward way to do it, but it's about getting your hands dirty and trying to be valuable to the community and the entire project as it's going. So, yep. And with that, let's dive down into the technical work that you are doing right now, which is BIP324, and it's about improving the P2P network privacy. So, let's dig down into it and carry on.
Yeah. So today I'm really excited to be talking about BIP324 as Raj told is a proposal to improve the peer-to-peer network privacy. So let's take a quick look at what the peer-to-peer network is and what's wrong with it today. This is the peer-to-peer network. It's a gossip network. The blue circles which you see, they are nodes, and they all announce different transactions, blocks, peers they know to each other. And how they communicate is by sending network messages. So common network messages include version. Like that's the first message which you send when you want to establish a new connection to a peer. The ping message, that's what you send when you want to check if you're still connected to a node. Or get adder, that is when you want to get more peer addresses to connect to. So the first problem is that all of the uh, network messages are self-revealing. They have this exact same basic structure. They always start with 4 bytes network magic. So Magic bytes are what identifies a network. So Bitcoin mainnet would have a different set of magic bytes compared to the Bitcoin testnet. And you could be able to easily understand if you're running a Bitcoin node by observing these packets. And people as in ISPs could decide to drop Bitcoin packets if they wanted to. So,
So the packets are in general like identifiable, like, and not only where it's coming from, but the entire data that it contains. And so it can also like contain other kind of commands and payloads, and the network traffic manager or the administrator can see all of that clearly, right?
yeah, exactly.
Right. Okay.
And yeah, using Wireshark, for example, this is a packet analyzer. And
Mhm.
like you can see Bitcoin protocol is being used and all the
Right.
details.
Right. And it can also see which node is communicating to which node in what command.
Yeah.
Right.
So the second problem is also related. All the network messages are unencrypted. So you might think, why do we need to encrypt peer-to-peer traffic? Because all transactions and blocks, they're going to end up in the public blockchain anyways. So the thing is,
Mhm.
there are global passive observers who can see a lot of peer-to-peer connections, like internet service providers. So they could identify where a transaction was first broadcast from and infer who is transacting with whom. Or they could observe where a block originated from first and infer where the miners in the topology are located. And this is all pretty useful information if ever they want to partition the network.
Right.
And the third problem is that it's unauthenticated. So, authentication can be interpreted in two different ways here. First is whether the connection itself is unauthenticated, and the second way is the network packet is unauthenticated. So, the first interpretation is what's shown in this slide. It involves the concept of identity. That is, suppose Alice is running a node and wants to send a network message to Bob, who's also running a node. Will Bob be able to know that the packet is from actual Alice and not somebody pretending to be Alice?
Hmm.
This is not done in the Bitcoin protocol today. And would we want this?
Right. And
Yeah.
this seems like it has to involve some kind of digital signatures into it somewhere.
Yeah, it involves a concept of identities, and bringing this into the protocol would be complicated because it's always restricted to specific scenarios. Like if you are the operator of both peers.
Hmm.
Yeah, so we don't want to do this now because it's too complicated and it's always restricted to specific scenarios.
Okay.
And then the second interpretation of authentication is what we are concerned with. That is, if Bob receives a message, he has no idea who it is from, but he should know if that packet has been tampered with. So this
Okay. Whether
isn't
the
done in,
message is correct or not.
yeah, and this is not done in the Bitcoin protocol today, and it would be something that is desirable.
Hmm. Right. So right now, what would happen like if the package is not like or a corrupt package came? Most of the cases, like the node will probably try to drop it, or like it said like that's not a right packet, and I'm not going to react to it. Is there an adverse situation that an adversary can create by manipulating packets in a certain kind of ways?
Uh, I don't remember the exact detail, but there was some PR where they talked about this situation happening in firewalls. Like
Hmm.
firewalls were tampering with the packets, but the solution, if I remember correctly, what they did is they decided uh, to just let it be.
Okay. Because you cannot like from a malformed package you can't really decipher whether it was intentionally malformed or some firewall in between did that.
Yeah, exactly. They decided to put it off till some authentication scheme comes later in the protocol.
Okay, makes sense. Okay,
Yeah.
you can go
So
ahead.
yeah. So so we know now that Bitcoin is self-revealing, unencrypted, and unauthenticated kind of protocol. So we want a new protocol which should have uh, opportunistic encryption, mild bandwidth reduction, and upgradability, and it should tackle all the previous problems. So this is what's happening right now. So if you want to connect to a new peer, you would first send a version message, and you get a Verac back. That's called a version handshake, and all these messages will be exchanged in plain text. So that's what's happening right now.
Mhm.
So if BIP324 gets merged, what would happen is if there are two peers, uh, you would first do an initial V2 handshake. We'll talk about that later, but this is different from the version handshake.
Okay,
And this would establish keys to encrypt and decrypt network messages. And
okay,
all the messages which are exchanged between peers would be pseudo random bytes and encrypted.
okay. That solves the problem of visibility. Now,
Yes.
the Wireshark will basically see like random blob of data passing around between peers.
Yeah.
Cool.
So then there's this question: why not just run the nodes over Tor since they would encrypt packets. So, like situations like this often happen. Distributed denial of service attacks on Tor. Tor
Mhm.
already has high latency than ClearNet networks, and
Right.
then with this, it's even slow.
Right.
Also,
And this has been happening for Tor for last few months a lot. And but the Tor was like the entire global Tor network was slowed down.
yeah, and then we'd also not want to depend on Tor to run our nodes. We want a solution that will work everywhere.
Right.
Also, network partition attacks on Tor are cheaper than on the real internet because controlling a lot of IP addresses, it's very hard.
Mm,
But you can get thousands of new Tor identities because they're just public keys.
right.
So we come to the goals of Web 324. First is we want something which should have confidentiality against passive attacks. As a passive attacker, you shouldn't be able to read what data is being sent. So now that passive attacks don't work, we need observability of active attacks. So attackers will have to become active now. Then we'd want pseudo-random byte stream because every single byte needs to look like a random byte, no magic bytes, and that self-revealing structure which we talked about before. We'd also want a shapeable byte stream to increase the resistance to traffic analysis. And we'd want forward secrecy. That is, suppose an attacker learns of some secret keys, they should only be able to decrypt the last few messages and not all the messages that have been sent between the nodes.
Okay.
Uh, we'd want upgradability. That is, in future, if you want to add authentication or post quantum crypto, that should be possible. Compatibility. Uh, we will call BIP324 enabled clients as V2 clients in this presentation and other references. So they should be able to communicate even with V1 clients. That is the current protocol, current
Right.
bit, current nodes. Wait, nodes running the current Bitcoin protocol.
Yeah.
So
So the
the,
new version of nodes would be saying like, hey, if you are an old friend, I will talk to you in the old ways, and it will basically like have like then it will basically have like multiple connections. Some are encrypted, some are non-encrypted, right?
yeah, V2 clients should be able to accept connections even from V1 clients, basically.
Right. But it will try to open, or it makes sense for it to try to open predominantly to other V2 client. But if there are not enough V2 clients out there, then it would also have to open connections to other V1 clients.
Uh, right now, we are not doing any preference for the peers. Like
Okay.
if if there is someone supporting V2 connections, we would open V2 with them. Otherwise, we would
Okay.
do V1 with them. And then low overhead. Like we don't want any significant increase in computational resources or bandwidth to run this protocol.
Makes sense.
Then let's recap a few concepts and put them together and design the new protocol. First is a very basic concept from cryptography. Like if you have a message and you want to encrypt it, you need a secret key which is random. You XOR with it, and then you'd get the cipher text. Similarly, if you want to decrypt it, you XOR the cipher text with the secret key, and you get the message back. So if there's an initiator node and a responder node, both of them would need the exact same keys in order to encrypt and decrypt. So that's one fact. Second thing is version handshake. So right now, how you connect to a peer is by sending a version message to it, and the peer would respond back with a VERAC. So we want even these network messages to be encrypted. So the initiator and responder would need the keys even before the version handshake. So that's the
Right.
second fact. And the third thing is like our problem will be solved if we know a way by which initiator and responder nodes who do not trust each other will be able to communicate over an insecure channel and arrive at the same keys.
Right. So that's the Diffie-Hellman key exchange protocol.
Yes. And since that exists, like it's pretty easy.
Mhm.
Uh,
Can I go over the protocol because this seems like a nice graphics of what happens in a protocol. So user A has a private key A and user B has a private key B. Then what
yes.
happens?
So the elliptic curve has a generator called capital P, and how you would generate a public key from a private key is by multiplying the private key with its generator.
Right.
So from a private key, you can always get a public key, but to go reverse, that is from a public key, if you want to get a private key, that's violating some mathematical properties,
Yeah.
and it's not possible.
It's a
So if you have,
computationally hard problem.
yes, and so user A would be able to know the private key as well as the public key. And then user A gets the public key of user B. And user A multiplies the public key of user B, which is B times P, with its private key. And it gets the shared secret, which is the private key of A multiplied by the public key of B.
Hmm.
And
And
similarly,
it
user
becomes
B,
A times B times P.
yeah, A times B times P is the shared secret.
Right.
Similarly, user B follows the same steps and by multiplying its private key with the public key of A. And it also arrives at A times B times B. But the adversary has access only to public keys of A and public keys of B. That's A times P and B times P. So if it needs to come at the shared, if it needs to arrive at the shared secret, and it knows this public key of A, it needs to know the private key of B, which it doesn't know.
Right. Or vice versa. If it knows the public key of B, it needs to find the private key of A, which it doesn't. And because the elliptic curve is discrete logarithm is hard, so from the public key, it's cryptographically guaranteed that they cannot find the private key also. So there is no way for an adversary listening to the communication to infer both the private keys of each other and consequently the shared secret.
Yeah. So
Cool.
we found a
That's
way, yeah, we found a way in which two people could come at the same shared secret. And then one more thing, because we are exchanging actual public keys on the wire, they are detectable because public keys are essentially elliptic curve points and they would always satisfy this equation, sec P256K1 for Bitcoin. And so we need to hide that. So for that, we use another cryptographic technique called alligator swift, which would convert this point into a uniform byte string. So
okay.
we use this cryptography too.
Okay. And then from that byte string, the actual key is also recoverable.
Yeah, the public key is recoverable. You
Okay.
can decode the public key back.
Okay. So does that require any special knowledge of private keys? Like if a node can do that, why can't an adversary, listening adversary or passive listener can do that?
Yeah, it's a uniform byte string. So it's pseudo random bytes. So why would an adversary suspect it to be a Bitcoin node?
Ah, okay. Right. So the security lies over there that the adversary doesn't know that it's a, but if it knows that it's a Bitcoin, probably a Bitcoin communication, but probably there is no way to identify this part of pseudo random sequence of the public key also from the wire data.
Yeah.
Okay, makes sense.
So we're going to put all this together and make a design. So we have node 1 and node 2. They have node 1 has private key small x and public key capital X. Node 2, which is the responder, has private key small y and public key capital Y.
Hmm.
So in order to design this protocol, we know that these two nodes, they need the same keys. So they would arrive at the same keys by exchanging public keys on the wire using elliptic curve Diffie-Hellman, which we saw before. And in order to hide the public keys, which we are exchanging on the wire, we would use an alligator swift encoding. So that's what's basically happening here. So node 1 would send its public key to node 2. And it wouldn't be just the public key, it would be the alligator swift encoding of its public key to node 2. So node 2 would be able to get the public key of node 1, and it does elliptic curve Diffie-Hellman with its private key. And it does some more key derivation functions to get all the keys to encrypt and decrypt the connections. And also a session ID, which would identify the session. And then what
Right.
node 2 does is node 2 would send back the alligator swift encoding of its public key along with the transport version. Transport version is something which we use in order to pave the path for future upgradability. Right now, we are sending empty messages as transport version. But supposing in future authentication or something is added, these protocols would have a different transport version assigned. And the nodes would communicate at whatever is minimum supported between both of them.
Okay. And what is E of nodes transport version?
Oh, so I just meant it's encrypted. Right now, you
Okay.
have the keys, so you could encrypt this.
Okay. So
And then,
after having the first, okay, no, wait. So node 1 sent the public key to node 2, and then node 2 will send his public key to node Y, and at the same time put some encrypted data. And that's not a problem because node 1 already knows how to decrypt it.
yes.
Oh, because node 2 is already sending the elliptic curve, so the public key of itself along with the data. So then node 1 can do the ECDH with it and find the derivation key and then can decrypt the transport version.
Yeah, exactly.
Okay, makes
The
sense.
node 1 would also send back its transport version to node 2. And
Okay,
both of them in future would communicate in whatever's minimum supported between both of them.
right. So is this how the new version handshake or the network handshaking protocol looks like in
No, this is
BIP324 world?
no, this is not what it's done because there's a very detectable pattern here.
Okay.
Do you want to take a shot?
Okay, let me try to figure. Okay, there is a detectable pattern of doing this, and I think the size of the transmission
Yes.
is known, right?
Yeah.
So we can see like this size of blob of data is being transported, so that might be a version handshake going on.
Yeah. That's correct. So always you're sending node 1 will always send 64 bytes first. And then node 2 would respond back with 64 bytes plus some fixed number of bytes. And
Okay.
this is also a fixed number of bytes. So it's a very detectable pattern and it can be observed during traffic analysis.
Okay. Makes sense.
So we
So
want to do
what about
better.
it? Okay.
Yeah. So instead of just sending alligator swift encoding to the other node, we also send some garbage bytes.
Mm-hmm.
So this is a variable pseudo random bytes. And like we also need to be able to tell the other node that we have stopped sending garbage. So for that is something called a terminator also. Okay.
Okay.
Yeah. So this terminator is something which we get from the uh, ECDH. Like
Okay.
from ECDH, you can derive the key session ID and also the garbage terminators. So what happens is node 1 now sends alligator swift encoding of its public key and a lot of garbage to node 2. Node 2, once it gets the 64 bytes alligator swift, it will be able to do ECDH and arrive at all these keys. Then node 2 would respond back with all its alligator swift encoding of its public key, lots of garbage, and terminator to tell node 1 that I've stopped sending garbage. It should also authenticate this garbage to make sure that no one has tampered with this garbage and send that as a packet
Okay. So it's an
in addition to
encryption
the
of a byte array, and where AAT equals to garbage. What does that mean?
yeah so it's yeah so the garbage is some additional authenticated data. B means empty byte stream, so the message which you are encrypting is empty, but for authentication purposes we are using some additional garbage. This is
Okay.
yeah this is something which is nuanced for that particular cryptographic structure.
Okay. Cool.
Yeah. So it's essentially the only things which you've added here is the garbage, the terminator, and this packet which would authenticate the garbage. So this would fail if somebody had tampered with the garbage.
Okay. Uh-huh. So if the garbage 2 on the previous line changes, then this will fail because the same garbage 2 will not be matched with the authentication of the data.
Yes,
Right.
exactly. So those three things are the new stuff which are added here. And then node 1 would get uh, the public key and will be able to do ECDH and arrive at all the four keys session ID. And then since it also gets the terminator actually from key derivation. And since it gets the terminator, it can send the terminator. So it will keep sending garbage and it will send the terminator finally.
Mm-hmm. Okay.
Does that make sense? Like terminator is something which is derived along with HKDF. Like you derive four
Right.
keys plus session ID.
But
I should have written
why is
plus
the
terminator.
terminator same for both the nodes?
Okay, they're different terminators. So node 2 would send terminator 2 and node 1
Okay.
would send terminator 1.
Uh-huh. So they both will derive both the terminators.
Yes.
Okay. Is there any reason of having like two separate terminators, not just one single byte that if both of them agrees like this is our terminator for everything?
Hmm. That's an interesting question. I'll have to think
Okay.
about it.
Yeah. Maybe something like there are I'm sure there are certain nuances behind it.
Yeah.
Okay, we can
Yeah.
carry on. So node 1 sends a terminator and another encrypted garbage data, and then plus encrypted transport version. Okay, so now this doesn't have the like the detectability problem and certain kind of fingerprints because the garbage length will basically vary.
Yeah. Node 1 would always send some, it's not exactly 64 bytes, but greater than or equal to 64 bytes here.
Okay, So minimum 64 bytes of garbage data has to be there.
Yeah. And then node 2, after receiving that, only after it receives greater than equal to 64 bytes, it should respond back to node 1.
Oh, sorry. So it's total greater than equals to 64 byte. A garbage can be 0 byte also.
Yeah, it can be 0 bytes.
Okay.
So, uh, so that's what happens, but there's still a detectable pattern here,
Okay.
which is what you said. It will always send greater than or equal to 64 bytes. And node 2 would respond only after it has received at least 64 bytes.
Okay. Hmm.
Does that make sense?
That does make sense. Yep. But yeah, now I don't know how to solve it anymore.
Yeah, so we need to do even better.
Okay.
So, so what happens is if Node 1 and Node 2 were running the current Bitcoin protocol, the V1 protocol, what they would do is first message which they would send is the version message. And the version message, as you know, for V1 P2P messages, they always have the exact same structure. The first 4 bytes are the magic bytes, next 12 bytes are the command, and so on. So for the version message, it would always start with first 4 bytes magic bytes, then VERSION in the commands.
Hmm.
So we know the exact bytes, like the exact bytes which should happen if a V1 connection was attempted. It's
Makes
like
sense.
it would always be the first 4 bytes network magic and then 8 bytes of version.
Right.
So, right, but if it's V2, it would be 64 bytes of alligator Swift. But it's
Right.
possible that in the 64 bytes, maybe the first 4 bytes is network magic and the rest 60 bytes is something totally different. Though it's a very remote possibility, it's possible that the
Hmm.
first 4 bytes match. So
Hmm.
what we do is node 2 will not wait to receive all 64 bytes. It would wait it until the first mismatch happens. Mismatch from the 4 bytes network magic and 8 bytes version. That would
Okay.
have to happen at some point if you're communicating at V2.
Okay.
So usually it's always the first byte itself.
Yeah, mostly because it's very unlikely that the first 4 bytes of a public key or allocated swifted public key will match with the network messages. Like very
Yeah,
low probability, but very small time it will happen. But most of the time, the mismatch gonna happen at the very start, and it will
yeah,
know like this is not a V1. Either it's like completely garbage or some kind of V2 communication is trying to happen.
hmm, yeah, exactly. So whenever the first mismatch happens here, you can immediately respond back with alligator Swift encoding of node 2. And then node 2, it would immediately respond back, and then node 2 would be still waiting for receiving the remaining alligator Swift encoding. Like it would wait till all the 64 bytes are received, and after it has received all 64 bytes, it would do the ECDH and derive all the keys. But before that itself, it has already sent the alligator Swift encoding of its public key to node 1.
Okay, because it kind of anticipated that it's a version 2 handshake.
Yeah.
Okay.
So this is a much better design, right? Because before node 2 would respond only after greater than or equal to 64 bytes was received. Now it responds after greater than or equal to 1 byte. And this is what's
Right.
used in BIP324. And this is what we call the initial V2 handshake. And
Okay. And because this communication is happening simultaneously, so now it's not fixed chunk of packets flowing from one side to another. It's like communication happening parallelly together.
yeah,
Okay.
so with this, we can get all the keys to encrypt, decrypt.
Right. And at the same time solve the pattern recognition thing.
Yeah.
Okay, cool.
And we can think of V2 protocol happening in three phases. First is the key exchange phase, where the alligator Swift encoding of public keys were exchanged. Then version negotiation phase, where they exchange transport versions. and application phase where all the rest of application level messages like version, verac, get adder,
Right.
all of those are exchanged.
Okay.
So now we've looked into how the bootstrapping of a node into the network is hidden using the initial V2 handshake. But then we also need an authenticated encryption cipher so that all messages exchanged between the peers are encrypted.
Okay.
So BIP324 also explains an encryption scheme, and all the bytes would be pseudo random byte stream. We'll not look
Okay.
into the details because it'll take too long.
Hmm.
Yeah, and then there's been more than 6 years of discussion into the ideas behind this BIP,
Yeah.
and yeah, the
So
draft was.
BIP324.com is like all the information if somebody is interested to get about BIP324 and all the progress of the status of the current work that is happening.
Yeah, that's the place to go.
Totally. Okay.
And then if you want to run a BIP324 enabled node, there is PR24545 on Bitcoin Core repository, which you can go. Uh, and all the testing instructions are listed here. You can get that link from BIP324.com.
Okay. And you can compile it and run a version 2 compatible node. So how is there any version 2 compatible node running on the main net right now?
Yeah, lots.
A lot of them. Okay.
A lot means maybe like, I don't know, 10 to
Like
20.
yeah, in the sense like all the people who are like testing with the open PR.
Yeah.
Okay.
So anyone can do this. It's just getting all the branches, building it, and running the node. I have to
And
do
does it
it.
with just one question that does it need that V2 transport equals to one flag or it's on by default?
It's not on by default. You have to set this flag.
Okay.
V2 transport is one. And if you want to attempt a V2 connection, you have to put this as true too.
Okay. So there is an extra argument for the add node command which you need to set as true.
Yeah.
Okay. And provided like the onion address of that peer, the peer we're trying to talk with also like supports v2. Yeah, that's the get peer info, and it's saying like service name p2p v2.
The
Right.
transport protocol type is V2, and you'd also get a session ID, and you can compare it with the other peer if you know the peer operator to make sure that no man in the middle attack has happened.
Right. Okay.
Yeah, a quick summary. Bitcoin Transport Protocol, we saw it self-revealing, unencrypted and unauthenticated. And BIP324 proposes a new V2 transport protocol with opportunistic encryption. And we saw how the initial V2 handshake is done and how packets are encrypted now.
Cool. So okay, you're at the end, so I'll let you finish it off, then I'll ask some questions.
Yeah, that's it. Thank you. Any doubts, you can contact me.
Yep. Do contact Spherostat, Stratospher, however you find her, depending on which platform you are looking for. Do contact her if you are interested in BIP324, and if you are in general interested in getting deep dive and get your knees dirty into Bitcoin Core protocol layer work, which is very interesting P2P peer networking infrastructure layer work. Do get involved with BIP324 efforts, and the more the developers who join in this effort, the faster we will get them done. And even if you are like working not exactly interested into working for BIP24, getting into reviews and adding comments, running a BIP324 node, testing it out also helps. And so one question I had was like the encryption that we are doing, is there any quantification of how much extra bandwidth it's gonna cost or any numbers we have like that?
Uh, like the computational power was kind of same, or if I remember, I think 97% compute compared to how V1 is running right now.
Okay.
And like there is, I mean, I don't remember the exact numbers, but we'll find those details in the BIP.
Okay.
The point is, there is not much extra bandwidth or compute required to do this encryption decryption.
Okay. So this will not like adversely affect the performance of the node in any meaningful way.
Yeah, actually, it kind of makes it a better,
It kind of makes it even better.
better. Yeah,
Okay, that's cool. And it also allows to safeguard the Bitcoin P2P network from all sorts of kind of analysis. Like, so by looking at the data and where they're coming and where they're going, we could like figure out the topology. And by figuring out the topology, we can perform a lot of different kind of like active attack and things like that. And also, like, even if there isn't an active attacker, like the passive attack can happen where an ISP can like have a policy to keep dropping all the Bitcoin related transitions and data to their network, and this defends Bitcoin against such kind of censorship.
yeah. It definitely like passive attacks are kind of very hard right now, but I think even still, it just raises the cost. Like you'll have to do more better ways of passive attacks. Like I think you'd have to observe bandwidth spikes in the network and things like that to see how transactions propagate.
But that's the nature of in general security and cryptography also. It's always like this cat and mouse game. There is like no one
Yeah,
perfect solution for everything. And it's like the attack surface, as you like defend against certain kind of surfaces, other kind of surfaces goes on, and it boils down to the question like how much somebody wanna actually stop it. And
yeah,
yep, so that's in general like in our nature and the trade-off of like Bitcoin designs. And these are like the kind of interesting question a Bitcoin protocol developer needs to like dabble with. And some in many cases there are like clear trade-offs and problems that even if we like to make them solve, or even if we like to solve them, it there is like um, no real easy way to do that, either without adversely impacting the performance, or or by creating some other kind of trade-offs somewhere else, either in scalability or in decentralization. So yep. And so what is the status of BIP324 right now? How long we can expect for it to get merged into code?
it's code ready now. We need lots more community review, so
Mhm.
it's stalled on that.
Okay, and how has been the approach and the response of the community in general?
Slow, but I'm hopeful. I think we are moving on next
Slow
month.
is, I guess, okay. I'm like more looking for something more dramatic. Like, is there any concept knack over there in the PR?
Ah, no, I don't think so.
So,
Though
in
people are
general,
discussing more details,
hmm,
like they are debating about the finer details.
right, but it's not a controversial change at all. In general,
Yeah,
the community expect it to happen.
I think we need it, especially if we want to make it Bitcoin censorship resistant.
Yeah, totally makes sense. Hmm. Okay, thanks for this nice presentation. After this, we would like to talk about a little bit light topics on Bitcoin. How does that sound to you?
Yeah, sure.
Totally. So, tell us a bit about your work. Like, how does working on Bitcoin feels like? What does the day look like for a Bitcoin developer?
Ah, it's very free, very flexible. You can decide what to prioritize each week and each day. There is that complete freedom of choice. It's both good and bad. Good as in you can work on all interesting stuff you like. Bad because
Right.
sometimes it becomes overwhelming.
Right. And how do you go about structuring what you need to do without like getting diverted into a lot of different rabbit holes here and there? You
Yeah.
have some kind of like method that you fleshed out for yourself?
I'm still experimenting. I keep like every week I have a set of like I write down like a list of goals, PRs I would like to review, concepts I would like to learn about, and detail it very specifically so that I don't go too deep into rabbit holes. And
Right.
I measure progress by seeing how much I could hit.
Makes sense. And where do you go for for things that you're stuck with and you can't really find the answer in Google? Do you go about try to experiment it out until you find it, or in general you try to ask for help wherever you can?
Yeah, I mean, normally, like first thing, like debuggers are my favorite thing. That's something I always go to. Uh,
Mm-hmm.
Logging, like I write log statements in different parts of the code base, read the log files, run nodes, and I do all those groundwork. And if I still cannot find it, I search IRC logs,
Mm-hmm.
uh, Bitcoin Core devs IRC logs, or Stack Exchange and stuff like that. If I still don't get it, I ask people.
Right. And how have been your experience working with other Bitcoin developers in the space?
They are amazing. Like,
Yeah.
I'm like really eternally grateful to everything I've learned from them. They are very
Mm-hmm.
freedom loving people with very deep philosophies about the money and how the world should look like.
Mm-hmm. Totally. And it is a very unique kind of space to work on, right?
Yeah.
So, do you have this kind of conversation with your other techie friends, and do they feel like you are working in tech, but in a very different kind of way that they are working? And are they curious about this? Like, do they come and ask you like what you do and how you're doing it, why you are not going to an office, why don't you have a boss and deadlines and stuffs like that?
Yeah, yeah, definitely. They're always fun conversations.
Right. And have you been able to like convert any of your friend into Bitcoin development?
Not yet, but still hopeful.
Yeah. Yeah. Okay. Keep on that fire on, and like, yeah, eventually, like you are definitely a big inspiration to all the young Bitcoin developers. Sorry, coming into the field and the aspirants. And so, yep, keep on having that conversations and keep inspiring people. And so, how do you find the Bitcoin community you see around in India? Like, where you always have been involved with them, always have been trying to find people around, and how do you see other? Do you have Bitcoin developers around where you are stationed and operating from?
Oh, actually, no. Like that's a little bit sad part. But I think I got involved with the community and saw that there is a huge Bitcoin community even in India than what I imagined it to be at Goa conference. That's when I
Mm-hmm.
met you and a lot of other amazing Bitcoin devs and heard about projects what everybody else was working on. So that was a very
Right.
fun experience. And I feel
Yeah.
like I've
And
got connected to more people after that.
mm-hmm.
And we still
Right.
keep in touch.
Right, totally. And if we Bitcoiners tend to like stick together because we are like so few in numbers, and we always
Yeah.
kind of like trying to connect and see what other ideas are out there, what other ideas are floating, and always keep that Bitcoin conversation flowing. So, what are the kind of things that you as a developer working professionally in the space would like to see more on the community side of the thing? What kind of like events or activities or things that you think like would get other young developers interested or like help out the existing developers who are working in the space? Do you have any thought on that?
Yeah, like I think in Indian, like India has a huge potential for Bitcoin development. It would be great to see bit devs and stuff like that happening in India, that we could delve into the technical aspects of Bitcoin.
Right.
And uh,
Okay.
like, was your question targeted at younger audiences?
In general, anything that in the community scene that you see is missing in India, that would help out both the younger audience or the younger people who are getting into it and all the people who are already working into it.
Mm. Yeah, more meetups, more
Hmm.
offline in real life culture. That would be great.
Right. There needs to be some more real life stuffs, right? Because we are kind of like doing it in internet all the time. So
Yeah,
being in real life actually helps out,
yeah, totally.
right? And so, do you have any like study material suggestions for people who are just starting? Maybe a student who is at your stage where you were 2 years ago and very interested to get into it, but don't exactly know where to start his Bitcoin technical learning journey. Do you have like study material suggestions for both cryptography, computer science, and Bitcoin technicals?
Ah, I think obviously the first one is Amiti's and John Attack's resources.
Mm-hmm.
Should I post the link somewhere?
Yeah,
Or
we'll post the link in the description of this
yeah,
video.
yeah. Those are really great resources when I first started. Actually, your blog article too was very inspiring.
Thank you so much.
Down the pit. That was also something I came out. Like those three articles was something when I saw when I first started out with Bitcoin.
Hmm. And
And
what about the more theoretical part of it? For like learning cryptography, have you been using certain kind of books or resources or courseworks?
oh, Dan Bonnet's Cryptography 1 course is something I enjoyed.
Hmm.
And I like, more than courses, I like a practical side to it. So I like, there's a platform called Crypto Hack where you can play, capture the flag games related to cryptography. So it's
Okay.
small concepts which you can learn by writing quick programs. That is
Hmm.
something which I enjoy more than sitting through a whole course.
Right. That's more probably a more fun way of like learning things, right?
Yeah.
And what are the resources that you used for understanding Bitcoin technicals? Like, did you went through the process of like mastering Bitcoin, grokking Bitcoin, those kind of books, or you directly straight jump into code and started figuring out from there?
Like I knew the basic fundamentals from grokking Bitcoin,
Mm-hmm.
and I think after that it was mostly a straight jump into core. But
Mm-hmm.
I found Fabian's that debugging Bitcoin core. Have you
Hmm.
seen that? Just yeah,
Yes, that's a very
that
helpful article for like people who are like trying to get into development of Bitcoin Core.
yeah, that was something which helped me like go through core in a more methodological way because you can
Right,
set breakpoints and go.
right. That's a really good suggestion. Yep, and I also have that. It's a GitHub gist, I think,
Yeah,
and it's a really good one. And I try to like refer it time to time whenever I need to figure out what was the way to like debug these kind of situations. And
yeah.
yep, that's helpful. And uh, in other parts of Bitcoin, like, are you also interested about the economics aspect of it, the philosophical aspect of it, and do you do some kind of study and have some books and suggestions on there?
That is something I want to develop. I mean,
Mm-hmm.
I've not had time to look more into those ideas.
Right. Okay.
But
Uh,
there is a list of books I want to read. I keep it on Goodreads, but I
okay.
have not. I can share the link maybe
Totally.
after the call. Yeah, I
Totally.
want to
That
read
would be
Bitcoin: A Work in Progress,
mhm.
Cryptonomics.
Right. Crypto economics is a really nice one. Bitcoin work in progress, I think, by George
S.
Provost.
Jobs. Yeah,
Yeah,
yeah.
that's a good one. And then there are like bunch of
Block
awesome
size war.
yeah, block size war is a really interesting one, and it goes into the social dynamics that happens on Bitcoin, and that's something like that really makes Bitcoin interesting and beyond just a software project. So that's a good one. What else I can think of? There's a bunch of book on I not exactly on Bitcoin, but in general on the path of internet and how it developed and how it kind of like has been affecting kinds of different parts of society in various ways. The book is called This Machine Kills Secret, and that's a good read. So yep, we'll list all these links in the description so the viewer can go ahead and read them at their own time. So, yep, this has been a fascinating conversation. Thanks for sitting with us. And hopefully, we can do more such kind of like technical deep dives later on and provide valuable technical contents. And thank you for all the work that you are doing for Bitcoin. And I hope you all the best for your career and path ahead in the space.
Thank you for having me.
Thank you so much.